Hello. Oh, hi.
Hi. Okay, this is my
Okay.
first actual live solve.
Wow, exciting.
Yes, 1,300 people.
Nice.
That's pretty big.
Yeah, pretty big. I was wondering like why there wasn't anyone in the meeting, and then I
Uh,
realized it only starts at 8. That makes so much more sense. Anyway, okay. So I guess we have like 25 minutes to just chill.
yes, that's good.
Wait, can they hear us by the way? I don't
Um,
know.
let's see. Are we on
Hi,
YouTube yet?
people.
Hi, everyone.
Oh, they heard us. Oh, wow.
Oh, yes, we are live. Okay, hi, YouTube.
Hi. Hi, everyone who's 25 minutes early. Wait, does the chat work? Let me see.
I think we're in a different Zoom. I think they're going to be
Yeah.
in.
Yeah, we're in like a different Zoom meeting. And then there's like something streaming from this Zoom meeting to the other one. Oh, chat relay is working. Nice. Well, I guess there's not much to prepare for this since it's a live solve. We kind of just
Yeah,
show up. That's the nice thing about live solves.
it's good. I already have that folder. Awesome.
Okay, I guess I will just be semi-AFK and do work while I'm waiting. Because I was wondering why this live solve was 1.5 hours. That did seem kind of weird. Makes sense now.
Yeah, an hour and a half would be a bit long for a live solve, I think.
Yeah.
Oh, we've got some people in chat already. All right, that's awesome. I see some people sending messages.
Whoa.
Okay,
Oh,
great.
wow. Hi, everyone. Nice to meet you.
We do have people coming 24 minutes early, which is really awesome.
Wow. Yeah, impressive. You guys are extremely dedicated. Either that or you just have nothing to do, which is also cool. Live solves are fun. So apparently Professor Lowe won't be in this live solve, so it'll just be us two, I guess. I guess like we just basically like alternate between questions and like that's it.
All right, that sounds good.
It's not much different because like when Professor Lowe is here, we alternate between the three of us. But yeah, not
Okay.
much different.
Awesome. I think we have some people from Math Kangaroo who are going to be joining us.
Oh, interesting. Cool. They might want to say a few words at the beginning. Like last time, the Math Kangaroo people said a few words at the beginning, and then we kind of just like had the rest of the time to ourselves.
Okay,
So yeah.
sounds good.
Hello. What? Wow, the number of people in the other meeting is increasing. Just just so you know, there's like one person in that meeting who's unmuted, just so you know. if you forgot to like mute or something. But like it hasn't started yet, so don't worry too much. Okay, there we go. So
Hi, Dylan.
hi everyone.
Yeah, it's just a quick reminder for
Hi.
anyone who just joined recently. We are not starting yet, but you got to see us already, which is really cool. And remember to
Yeah.
send your messages to chat relay, and they'll pop up on our screen just like this. And you might even earn some cool stars like Dylan just did.
Yeah. Yeah, so I see some people are already talking in chat, which is awesome. Let's see, do I have the slides yet? And for all of you who are here early, I guess you get to watch what happens behind the scenes 15 minutes before a live solve. We're just kind of like
Little,
getting stuff set up.
yeah, little special action for everyone.
Yeah. I still do not have access.
Yeah, I don't think I do either. That was a great question in chat. What is this and what is daily challenge? So this is going to be a live solve of the Math Kangaroo levels 5 and 6 competition. So basically, we're going to get to see some questions from a past competition, and we've never seen them before, and we're just going to solve them for you guys. And it's going to be a lot of fun.
Yeah. So this is not exactly like Daily Challenge. Like Daily Challenge is a brand of online courses and live courses that you can take. Like, and we are TAs, which are like basically people who like kind of teach daily challenge classes, but not really because Professor Lowe is also kind of there. So it's like a combination of us and Professor Lowe doing the teaching. But yeah, we're TAs from Daily Challenge and we're doing the live solve for you guys today. So we're going to be solving some Math Kangaroo problems. So like a video, well, there's two different things in Daily Challenge. You can either take the completely virtual class, which is not live. It's just like a bunch of videos and mini questions that you answer on an online website. And then there's also a live portion. So like if you want to take real-time classes with real teachers, you can sign up for live classes and there will be high schoolers like us teaching you. And Professor Lowe will be there too. He'll be there in the form of pre-recorded videos, but we can pretend that he's there in real time. So yeah, live courses are lots of fun.
Yeah, they really are. It's a great experience for everyone who's involved.
Yeah.
I see some people here are in our classes. I do recognize a lot of names, which is really awesome.
Oh yeah. Vibrant Flamingo. I recognize that type of name as like a daily challenge username. Nice. Yeah, feel free to ask us any questions you're curious about. There will probably be a few minutes to ask questions at the end, but if you have any burning questions now, go for it. Oh, so Stan says we're teaching how to solve difficult problems. Well, I'm not sure how difficult they are. I'm not sure like, what they even are, but yeah, we're going to be attempting solving math problems today. Oh, hi, Lucia.
Hi.
Yeah, Vibrant Klingon was in my class. Oh, awesome.
Together? Yeah, we are, well, okay, so we're probably going to like attempt them like by ourselves first. Like we're going to alternate problem by problem, but we might also like decide to help each other. Who knows? Ooh, Vibrant Flamingo, you were in Jesse's class before. That's funny because there's two Jessies in Daily Challenge. And like when you say Jesse, like when especially because the two spellings are like really similar, but yeah, that's funny. But both Jessies are amazing. So that's great.
And so just to add on, you guys will be involved too, right? Because you guys have chat relay, like we said.
Yeah.
So any messages you send, we can see. And if you guys send your answers or solutions, we might try and incorporate them into our answers. So
Yeah.
you guys are as involved as you can be.
Yeah. So like if you guys attempted one of these problems and you had a really cool solution, you could type it in chat or to like give us a hint or just to like share it for fun. That's cool.
Hi, Vivian, Jessie.
Mhm.
Nice to meet you. So I'm just wondering, so you are co-host for today event, yeah?
Yeah.
So I will give a brief opening and
Okay.
then I will pass over to you too, yeah?
Okay, awesome. Thanks. Sounds good.
Yeah, so I just got a message. So I think I missed a message from Xin. I just saw her message this afternoon. I'm not sure what happened to the mailbox. There is a lagging. So yeah, so I just found out. Yeah, so yeah.
Okay. Sounds good. Oh wait, I think what Debbie was talking about was not the slides, it was Michael's thing. So nothing has changed about the slides. Wait, we should like make sure that we actually have the slides in time. Maybe either spam ping scene or like call Po or something.
Okay, let me request access again.
Oh yeah, I should maybe request access.
I'm just wondering who will handle the chats during the meeting? During
Oh,
the
Oh,
Yeah.
we have some moderators, like other TAs behind the scenes managing the chat. So yeah,
Oh, that's great.
yeah, there's some people doing that. Shout out to Sriram and whoever else. I don't exactly remember.
Grab a lap.
Oh, it looks like she is online. Hi, everyone who's just joining. So we're just chilling. We have 10 minutes left. The event will start in 10 minutes. Oh, wait, you know what? When Professor Lowe is here, he often has like that 10-minute timer or something, or like 20-minute timer, right? We should do that,
Yeah,
except it wouldn't look as cool without like the professional daily challenge background.
do we have that? I might actually have the timer somewhere.
Really? Wow.
I think it might be in the slides.
Oh. Wait, let me use that. Seriously, another one? Okay, sad. Now you can't see me. Hmm. Okay, now you can kind of see me.
Awesome. Some people are requesting music. We don't have Kahoot music, but we have one better. We have
Wait.
our
Oh
thinking
my
music.
gosh. Yes. Thinking music. If you've taken daily challenge classes before, you know what we're talking about. Oh wait, I just realized you can only see the timer when I'm speaking. Oh well. Yes, this music. You can pretend that this is a daily challenge like timer, like one of those timers that you see during like a mini question or something. And you see, it's like almost the same color. Like the blue is like almost the daily challenge blue. Purple. Just, oh yeah.
It's pretty close.
Okay, you guys, I agree with you though. Like Kahoot music is pretty good. Except daily challenge music is more of the like thinking vibe, kind of. It fits more with this live stream, that is. Yeah, let's go. Wow, I see some of you recognize Jesse. Where is Chat Relay? So Chat Relay is like a bot. Where even is Chat Relay? I think it's like in both meetings, or like it's in like some combination of the two Zoom meetings, and like it's a bot basically that you direct message, and then it will like it will transfer your message onto the like the thing that the moderators see, and they can like give you a star if they think it's a particularly good message. They can give you an X if they think it's a particularly bad message, and otherwise they just like do nothing, and then it might show up on the screen. So yeah, it's like a nice little thing that makes the chat like show up on the bottom of the screen like a Twitch chat. Ooh, it looks like
Right?
Jesse. Ooh, Jesse, wait, you got it to work? Wow.
Yeah, I found it on an old YouTube video. I think it was actually one of the old Math Kangaroo live
Also, wait,
solves.
mine needs to be synced with yours.
Oh no.
Yeah,
It's
kind
just a
of
second
bad.
off.
Yeah, 1 second.
Okay, we see people who are here again. I'm glad you guys enjoyed it the first time and deciding to come back. Jaden, colors are assigned at random. People asking for free stars. Let's give them out to get some excitement going. I see a lot of really familiar names. Can you hear me?
Yeah, we can hear you.
Alright, I just heard someone ask to talk.
Oh yeah, okay, wait, so you guys can, let's say you can talk as long as it's in a controlled way for the next 5 minutes, because after that the meeting will have like 1,000 people and it's going to be kind of impossible for everyone to like talk without it being extremely chaotic.
Yes, we did have, I
Oh
believe,
shoot.
1,300 signups.
Oh shoot, maybe I shouldn't have let them talk. Is this a bad idea?
I don't know.
Hi. Wait, Jesse, we need the slides. Wait, hold on. Wait, we actually need
Yeah.
the slides. Should we like call Po?
Yeah, that might be a
Kind
good
of
idea.
bad.
Yeah.
Okay. Okay, I'll be right back then. I'm going to call Po. See you soon.
Okay, but for the next 4 minutes, 4 minutes and 39 seconds, I will be your live entertainment, even though you can't see me, but I'm giving you guys this great timer. So, does anyone have anything they want to talk about for the next? Okay, I will not sing. I am not a good singer. You good hummer? That's all good. Okay, unfortunately, I can't sing. Any other requests? There's things to talk about, some math questions. How many of you guys have done Math Kangaroo before? Okay, lots of people. Lots of people. Awesome. It's awesome. It's a really cool competition, and you guys are going to see some amazing problems today. I see we're getting close to 100 participants, which is amazing, and we're still 4 minutes out. Last I heard, we had close to 1,300 people signing up, which means that hopefully we'll get close to like 1,000 people today. So it'll be really fun. What grades is this for? This is for grades 5 and 6. Talk about random things, please. Okay, more people. We hit 100. That is very nice. What about 7 to 8? So they are bi-weekly, and basically, I believe 7 to 8 is in 2 weeks. I'm not completely sure. If you guys check out live.poshenlow.com/show, then you guys will see the schedule of all the upcoming live solves and events that we're doing. Yes, I can. Okay. Let me put it in chat relay.
Hi.
You have this stream on YouTube.
Oh wait, it's Vivian. Well, we don't have the slides, and you kind of need them.
Here, let me put the link in chat relay for you guys.
Yeah. Well, Steve made them.
Okay. And you guys, if you go onto that link, there's also a way for you to send messages to chat relay on there, in case you're not in the Zoom. And for anyone, oh, do we have people watching from YouTube? Is that what this is? Oh, okay. So for anyone joining us on YouTube,
until it starts.
let me see. Let me send this link in the YouTube chat for you guys. Okay, there we go.
Yeah, but we didn't have access.
Unfortunately, I'm not in the same Zoom as you guys. So, if you can just... Okay, let me see. Can anyone else that's in the Zoom... we don't have access to chat to everyone. So, unfortunately, we can't put it in that Zoom. But if you guys head over to the YouTube, you can see the link to send messages.
Okay, hi people. I know I'm unmuted. I was too lazy to mute myself.
That's alright.
Okay, let's see if we can get the slides. So, Po told me to put the link into Zoom 006 channel. And so let me just get the link. Okay. Hopefully we can obtain the slides in the next 1 minute. What time does it go till? It goes till 9 p.m. Eastern, 6 p.m. Pacific.
Eastern is the best time zone, though.
Debatable, but yeah.
Oh no, there's chat starting to show up on the video that I'm taking from. So if you guys see conflicting chat to the left, just ignore it.
Oh my gosh. Wait, Jesse, you're taking this from a real class? Wow.
Yeah, this is from one of the earlier Math Kangaroo videos that's currently on YouTube. What is the YouTube? The YouTube channel is Daily Challenge with
Yo, we
Po-Shen
have
and
access to the slides. Yes, let's go. With
Yay!
30 seconds to spare. Okay,
Okay,
awesome.
awesome. So,
I will
unfortunately, that
make
means I do
sure.
have to get rid of our timer, which is very sad.
Oof, it's okay. We have
I'll leave the
15
music
seconds
going.
left, everyone.
All right, we're at 170 people in the Zoom. This is amazing. I'm glad we have so many people joining us. Oh no, there we go. Stopped it just in time.
Okay. Wait.
Hello,
Okay.
everyone. Yeah. Do I start?
Yes, awesome.
Okay. Yeah.
Yeah.
Hello, everyone. Welcome to Daily Challenge with Math Kangaroo cooperating together for this workshop. My name is Lucia Liu. I'm a Math Kangaroo faculty and teach kids strategies and techniques in solving math problems. I started connection with Math Kangaroo since my son Noah was in third grade. At that time, we barely found any math competition for lower primary students until he met Math Kangaroo, who runs the competition from first grade to 12th grade. Noah has participated in Math Kangaroo competition every year from third grade to 11th grade. Now, he's a Math Kangaroo gold medalist and got a perfect SAT score in grade 10. Through Math Kangaroo, he found math is fun, math is cool, and math is everywhere. Math Kangaroo opened his mind on problem solving and critical thinking and laid a solid math foundation for him. Math Kangaroo not only hosts competitions every year, but also offers group and private lessons, webinars, and a lot of online math learning resources. Please visit mathkangaroo.org to find more information. Now, let me introduce two co-hosts from Daily Challenge for today, Vivian Luo and Jesse Brodman. Vivian is a Pennsylvania State Math Counts champion, a first goal winning this competition in 36 years. She's two-time MOP qualifier and a member of US team at 2022 EGMO. Jesse is a leader of statewide math competition program. He was placed top 6 in national math competition and got perfect score on USACO bronze. Now hand over to the hosts. Vivian and Jesse, please.
Okay, thank you so much for that introduction, Lucia.
Thank
Okay.
you.
So I guess it's time to get to the fun then. So for anyone who just joined, you can send your messages to chat relay, or if you would like them to show up on the bottom of our screen, just direct message chat relay. There should be an option in the chat box for like direct messaging. Yeah. Okay, so you want to get started? Should I take the first problem or do you want to, Jesse?
I'll let you get started today.
Okay, then here we go. So our first problem, hopefully the chat is not blocking it too much, but this is our first problem. I have not actually thought about this problem yet. This is my first time seeing it. So let's see how this goes. Looks like 6 points are numbered as shown, and there are 2 triangles, one by joining the even numbered points and one by joining the odd numbered points. Okay, so I guess it would look like this, because these are the even numbered points, and I should get another color. Wait, purple is like not a very good color to use, but anyway, okay. So we have 2 triangles, and then the inside of one triangle is red and the other is green. Oh, interesting. Oh, okay. So I just have to figure out which of those 5 it looks like. Okay. I'd say it looks like E because the other four don't have the triangles in the right position. Like regardless of color, they just don't have the correct triangles. So yeah, and it looks like you guys are saying E too, so that's a good sign. I think this is probably correct. Let's check the answer. And it is E. Yay, let's go. And in
Awesome.
general, yeah, wait, sorry, you can go, Jesse.
I was gonna say, awesome. I drew the same thing but different colors.
Nice. So yeah, in general, you guys can like feel free to type the answer or any ideas or hints you have in the chat. And yeah, we like to keep the chat active and full of great messages. So yeah, type anything useful you want to throw in. I guess it's on to you now, Jesse.
All right, awesome. Yeah. And you guys might notice that not all messages are showing on our screen. That's just because we're getting hundreds of messages, and it would completely fill up our screen if every single one of them went on. So definitely don't feel bad if your message isn't here. Just keep sending messages and you will get on. So let's look at question number 4. Cistercian numerals were used in the early 13th century. Any integer 1 to 99 can be represented by a single glyph formed by combining two of the glyphs shown below. The glyph for 24 looks like this cool, kind of reminds you like the wavy man symbol. And the glyph for 81 looks like another symbol. And the glyph for 93 looks like that symbol. So what does the glyph for 45 look like? And here it looks like we're given all of our symbols for 1 through 9, and then 10 through 90. All right. So let's just look at these symbols and see how we can make 24 out of what we're given. So 24, just a little reminder, looks kind of like this. So just on first look, based on the fact they give us each of these 2-digit numbers and a 4-digit number, I'm going to think that they combine them, right? They're going to take a 2-digit number and a 1-digit number and kind of morph them together. So let's draw the 2-digit one. So that's 20. All right, awesome. And a 4 looks like this. And you'll notice that if you put these two together and just make the one line the same, you do get 24. And you'll notice if you do the exact same thing for 93 and 45, you get the two symbols shown. Or not for 45, for 81 and 93. So let's just do the same thing for 45. Clear out what we wrote right here. All right, 40 looks like this. And a 5 looks like a little, I'd say like a flag, like a triangle maybe. All right, so these are our symbols for 40 and 5, and let's morph them together. So that means 45 should look kind of like this. And now let's look at our answer choices. Well, A looks pretty similar, but it's like rotated, or it's like flipped, I would say. C doesn't look the same. E doesn't look the same. B isn't morphed together, but D is. All right, so I'm seeing a lot of people say D in chat, which means they agree. And let's check our answer.
All right.
Awesome.
Yay, awesome. This is a cute little problem about like glyphs. Very cool problem. Okay, let's see what the next one is. Let me erase my whiteboard. Okay, let's see. Ooh, okay. So let me make this a bit big. Ooh, so we've got vehicles in a garage. Oh wow, this reminds me of the game Rush Hour. Have you guys played the game Rush Hour? It's like where you move the cars around. Actually, this looks exactly like Rush Hour.
Oh, I
It's
used to have
very
like a little
inspired.
set. I used to have like a physical set where like you could drag cars
Yeah,
around like
same.
tiles. Oh, that brings
Same.
back
Yeah,
memories.
those days. Oh, I think some of you guys might be unmuted too. Just as a reminder, like if you forgot to unmute, maybe unmute or something, but yeah. Because we kind of don't want like 1,300 people all talking at once. But yeah, I can tell like, wow, okay, people already have ideas, so maybe I should hurry up. Let's see. So what is the smallest number of vehicles that have to move out of the way for the black car? Or let's say it's white car because in my slides it's white. So say like white. To be able to exit the garage. Oh wow, okay, so this is a puzzle. So let's see. First of all, one thing I'm noticing is that this bus right here has to move because it's like blocking the car right in front. But then if you think about like where it has to move, oh wow, people are saying 4 in the chat. Wow, 4 is a lot. Oh my gosh. Hmm. Okay, so let's see. Where could the bus move? Oh, someone said I was right. Okay. Well, let's see. Looks like a lot of people agree with 4. Let's see. Okay. Okay, so as a reminder, I'm sorry for everyone who's like really enthusiastic about their answers, but please only use chat.
Yeah, okay.
Wait, hold up.
Just a reminder, guys, we have chat not unmuting.
Yeah.
That way everyone can hear what's happening and see what's
Yeah.
happening. So make sure you don't unmute and instead you send your messages to chat relay.
Yeah.
Guys, remember,
Okay, so
you can mute yourselves on the Zoom and send messages
yeah.
to chat relay.
I'm hearing a lot of good ideas out loud, but I would encourage you guys to only use chat because just for the sake of like organization, we would like everyone to use chat and not all unmute at once. Okay, thank you. DM chat relay. DM chat relay. It should be called chat relay, not daily challenge. Chat relay. Yeah. Yeah, no problem. Okay, back to the problem. Okay, so let's see, this bus, well, if it moves one spot up, that's still not enough. Wait, what? There should be an option to click like chat. Okay, I'd say it's because it seems like a lot of people have questions about chat relay. Maybe wait, hold on. They cannot put it in chat. So
Okay, guys,
you
how
have
about
to be DMing chat relay.
if your chats aren't going through, that's because we're getting so many different messages that not every single one of them can show up.
Yeah,
But if you're having
exactly.
difficulty DMing on Zoom, if you go to live.poshenlow.com/show, then you can also send your messages in through there instead of DMing.
Yeah.
Yeah, I will send it in chat.
Okay. Anyway, yeah. Lastly, like, yeah, if you want to know how to use chat, just like DM chat relay. And yeah, if your messages aren't showing up, there's actually a limit of 1 message to show up a second, just so the chat doesn't move extremely fast like that. So that's why maybe not all of your messages are showing up. Hmm. I'd say just I'm not sure. I don't think we have time to resolve all the technical difficulties, but just like do your best. Okay, congrats if it's working. I'm sorry if it doesn't, but hopefully it will eventually. Okay.
Yeah, I'll send it in chat one more time. But remember, guys, we do want to make sure we have time to solve all our problems.
Yeah,
So we want to make sure everyone like stops
we've
unmuting.
got a lot of cool problems to get through, so we kind of need to
Yeah,
like make
it's
sure
right
we're
here.
on schedule.
If you go to this link, then you can chat on there.
Okay.
Okay, sorry about that, guys. If you didn't see the link, it's okay. For anyone who didn't see the link, unfortunately, we can't send it any way other than that. So if you don't see it, unfortunately, for now, we'll work on a fix. But for now, we can't be using the chat if you can't like just DM them right now, and we can't keep having people unmuting because then we won't be able to keep
Yeah.
going. So
Yeah.
we're gonna go on. Hopefully, you guys do have access to the chat, but we will work on a fix for anyone who doesn't.
Yeah, we're sorry, but yeah, hopefully it works out for like most people. Okay, so anyway, back to the problem. So if the bus moves like exactly 1 unit up or 1 unit down, that wouldn't work because it would still be blocking the car. So it has to move, actually, it has to move 2 units down. Like the bus has to eventually occupy these bottom 3 rows because that's the only set of like 3 consecutive rows that won't block the car, the white car. So that means that like these 3 cells, wait, let me like color them in a different color. So these three pink cells that have circles in them must be occupied by that bus, so it cannot be occupied by anything else, which means this other bus, let's make it blue. So this blue bus must move. Oh, I'm sorry, that kind of covered up the pink, but anyway, that blue bus must move to the left. So, ooh, okay. So lastly, like please don't like interject with statements about the problems in chat. Even if you have really good ideas, please use the chat. Thank you so much. That would be useful. So yeah, please mute. Anyway, so the blue bus needs to move to the left, which means this car needs to move up. And okay, now I see where you guys are getting for. So like because this car needs to move up, it's going to need to push this yellow bus up. So how many things do we have moving in total? The yellow bus, the blue car, the blue bus, and the orange bus. So I guess that would be 4. I don't see any way to do it with less vehicles because it seems like all of these vehicles in the line kind of like cause each other to have to move, and so they all have to move. But like it's probably possible with like 5 and 6, but because this question asks for the smallest number, I think the answer would be 4. Let's see if that is the answer. Looks like a lot of people agree, which is awesome. Yeah, it is. Yay.
Okay. Yes,
Okay.
great job on that problem, everyone. Just another quick reminder to not unmute in the Zoom, because we do want to show you these really amazing problems.
Yeah. Oh, and by the way, like in real daily challenge classes, you can unmute basically whenever you want, unless it's not like over the board. But yeah, just in this particular meeting, please don't unmute. And for all the people who have their hands raised, I'm sorry, we probably won't get to call on you just because like there are so many people with good ideas in this meeting that we cannot call on all of them. But yeah. Okay.
All right, awesome. So let's go on to question, I believe this is question number 10, but it's our next question. So which of the following fractions of a whole turn should the Ferris wheel turn to bring a white pod to the top? So my first question when I look at this is, are we turning clockwise or counterclockwise? But look, there's the same, like it's the same distance no matter which way we turn. So it really doesn't matter which way we're spinning. So okay, if we have a white one right here and a white one right there, so that's 1, 2, and 1, 2. So it's going to be 2, like of the spins, we're going to have to, let's say each going to the next one is like 1 notch, right? So it takes 1 notch to go from here to here, 1 notch to go from here to here, 1 notch to go from here to here, and so on. So it'd take us 2 notches to go from one white to the next white. Okay, so let's just say that's 2 over, and now we need to figure out the total number of notches on our Ferris wheel. So here we have, I mean, it's probably easiest to count them out in pairs, because notice that every single white one is paired with a black one. So let's just pair up our groups. So that's 1 pair, 2, 3, 4, 5. Oh, my circles aren't the best, but that's okay. That's 5, and that's 6. So that means that there's 6 pairs for a total of 12 notches. Okay, so that means that's 2 over 12 is the fraction of the Ferris wheel that we have to turn. And notice that this isn't an answer, so we want to simplify it. And 2 over 12 simplifies to 1 over 6, which is answer choice C. All right, so I see a lot of people agreeing with me in chat, which is awesome. Let's check our answer. Some more diagrams. Oh, the answer is actually D, 112. So I think that that means that the colors were just off a little bit.
Yeah, wait, hold up. Okay, so this is like really complicated because in our slides, like sometimes the colors are inverted. So like when it says white, it might mean black. But anyway, like you kind of get the idea. If it was like the consecutive pause, then that would be like 1/12 because it's like 1/12 of the circle. If it was like 2 pause over, then that would be 1/6. So yeah, I think you guys get the general idea. Good job. And I'm sorry for all of you who have questions, but please direct your questions to chat relay. Hopefully they will get answered there. And yeah, so that we will have time to like go over as many questions as we can. yeah, if you guys like got the wrong answer, that's probably just because of like the weird colors. So don't worry too much about that. I'm sure it was all okay in the real competition.
Mhm.
Okay. Moving on. Ooh, so we've got containers of water. So let's see. We have a water tank with a rectangular base that has dimensions 1 by 2 by 4. Okay, so it looks like it's a rectangular prism with lengths 1, 2, and 4, and then it contains water to a depth of 25 centimeters. Okay, so the first picture has like a thin, like a shallow layer of water, 25 centimeters deep, and the second picture. Oh, okay. So now we're like we're like rotating the tank so that it's on its small end now. And I guess we want to find the depth of the water now. And so clearly it looks like a bit more like the depth seems a bit more deep, which kind of makes sense because if the base is smaller, then the height should be, if the base is smaller, then the height should be bigger so that it's the same volume overall. So, okay, I guess like, yeah, volume is the key idea here. Let's calculate the total volume of water. So total volume, we know that this is equal to length times width times height. And so here the height is 25 centimeters. How should I write that? Maybe I'll write that like 0.25. I think 25 centimeters is 0.25 meters because like centi is 100. Okay, so yeah, I'll just write that as like 0.25 meters times, how long were the other dimensions? 4 and 2. 4 times 2, which would be 1 times 2 equals 2 cubic meters. The meters cubed of water. Okay, and now all we have to do is notice that there's the same volume of water in the first and second diagrams. So if we call this height like h or something, then we get h times whatever the two dimensions of the base were in the second diagram, which is 1 and 2. So h times 1 times 2 equals 2 meters cubed, and then we can calculate h, and h ends up equaling 1, I think. So looks like the depth of the water now is 1. Ooh, awesome. Looks like people are agreeing in chat. That's always a good sign. Let's see, is it the correct answer? Yay, let's go.
All right, another awesome problem. Seems like everyone did great on there. So what better transition than another problem, right? So the year 2022 is a special year because the digit 2 appears 3 times. This is the third time that Eva the tortoise has lived through a year with 3 identical digits. What is the youngest age Eva could be by the end of 2022? Okay, so the youngest age means that we want to find the closest 2 years, because if this is the third year with 3 digits, that means that there were 2 before. We want to find the year that was 2 before this with 3 digits, and basically find the age they would be if Eva was born in that year. So let's get started. We know that if we have 2022, so 2000, and then we'll say that there's 3 digits here, right? Well, the next shortest thing would be to have all 3 of these the same, right? Because otherwise, if we had, right, we're not going to have anything higher than a 0 in this x. So it has to be 20xx. And we already have the 2 x's equaling the 2. So that means that our 1 year before this, where there's 3 digits that are the exact same, is going to be 2000, with both of these x's being zeros. So the first year is 2022, the second year is 2000, and now all we have to do is find our third year. Now let's go to another color because that's extra special. And if we're starting in the year 2000, well, that means that we want to jump back to the 1900s. But we need to figure out what year in the 1900s we're going for. So let's write 19xx. And if we want 3 digits to be the same, and we already have 2 distinct digits, that means that the x's are going to be either a 1 or a 9. So is our year going to be 1911 or 1999? Well, we want to figure out the closest year, right? Because we're going consecutively. So the closest year to 2000 is 1999 because it happens after 1911. All right, awesome. So that means 1999 is going to be the year that Eva was born in. So by the end of 2023, the oldest that Eva could be, well, you're going to age 1 year every time, right? So 2022 minus 1999, that gives us 23. So by the end of 2022, the youngest you could be is 23 if you were born in 1999. That gives us option D, and I see people agreeing in chat. I see Vivian also got the same answer. All of this is a great sign that it's the right answer, and let's check. And here we go, option D. Awesome.
Well, I mean, I have to say, like, it's between 1999 and 1911, right? And if the answer was like, if Eva was actually born in 1911, that would be one old tortoise. Like, I don't know, maybe tortoises do live for that long, but that would be one really old tortoise. Anyway, 1999 is still pretty old for a tortoise, I guess. I'm not sure. Maybe you guys know more about tortoise lifespans than me. But okay, let's continue. So. Yeah, I really like all of these questions, by the way. Like, they're all so creative. Okay. Let's see. Ooh, more animals. So this time we have 4 dogs. Each of the dogs weighs an integer number of kilograms. And no 2 of them weigh the same number of kilograms. Their total weight is 60, and the second heaviest weighs 28. Oh, interesting. Okay, so we've got 4 dogs. And the second heaviest weighs 28. Let's say they go increasing by weight. So like the rightmost one is the heaviest, the leftmost one is the lightest. So how heavy is the third heaviest dog? Wait, this is really interesting because like it's implying that there's one answer. Like there's only one possibility for how heavy the third heaviest dog is, which is pretty cool, I think. So let's see. How could there only be one option? See, I mean, 60, okay, 60 is not that big of a number. Like, okay, we know that this heaviest dog must weigh more than 28 since it's heavier than the 28, right? And the third heaviest must weigh less than 28. Oh, okay, I see where things are getting kind of like forced. Okay, so first of all, let me circle this one because like this is like the thing we know. This is our known. And so since the heaviest dog must weigh more than 28, and there's only 60 kilograms total, then basically we're going to have 2 really heavy dogs and 2 really light dogs, since 28 is almost half of 60. So the heaviest 2 dogs will almost make up like 100% of the weight, basically. Oh, and just a reminder, please don't unmute just for the sake of like having this go smoothly. So yeah, direct all your messages to chat relay. Anyway, ooh, okay, people are typing answers in the chat. Wow, cool. I'm sorry, but please don't interrupt by unmuting. Hopefully you can get your chat to work somehow. Okay, maybe it's because like there's kind of a lottery system going on in chat and like your messages won't always show up because only one message can show up a second. I'm sorry, that is the unfortunate thing about having like 1,000 people in a Zoom meeting. But yeah, please mute. Okay. Yeah, and we're really sorry about that. So, why can't the meeting host just mute everybody? Like, that's a good idea, but I'm not the meeting host. I'm not sure who it is, but yeah, it looks like Daily Challenge is the host, which is like probably one of our team members, but I'm not sure. Anyway, okay. So back to the problem. We're almost done. So let's see. Let's just like, I don't know, test values for the heaviest dog. So it could be 29, right? Because 29 is bigger than 28. If the heaviest dog is 29, then so the sum of 2 lightest plus 28 plus 29 equals 60, which means solving for 2 lightest. Oh, I'm sorry, this kind of looks like 2 times lightest, but really it's just like the quantity 2 lightest. So like 2 lightest equals 60 minus 28 minus 29, which is 3, I think. And then, oh, okay, so this is cool. Because they're all different weights, if we have two different numbers adding to 3, there's only one possibility. So because they add to 3, they must be 1 and 2. And then how do we know the heaviest dog has to be 29? Like, why can't it be like 30 or 31? Well, if we try to make the heaviest dog even heavier, the sum of the two lightest would be even smaller. And it's impossible to have two different numbers, two different positive integers summing to less than 3, because that's just impossible. So heaviest cannot be greater than 29. Therefore, heaviest is equal to 29, and so we have 1, 2, 28, and 29. Like people in chat were saying, good job. I see lots of people saying A. Yeah, okay, so I guess the answer is A then. What if the dogs weigh 0? That would be that would be a very interesting universe, but I don't think dogs on Earth weigh 0. So yeah, unfortunately, we don't have any. Oh yeah, I don't think we have any like issues with this. So it looks pretty good. Let's see, and the answer is 2. Good job, everyone.
All right, awesome. Okay, one more quick reminder. Please mute yourselves. I do believe I hear someone that's unmuted. So we want to make sure that everyone can hear what we're saying and just have a great experience. And to do that, we need everyone in the main Zoom to be muted. But let's... What was that? You have to DM chat relay. That is our way of communication instead of unmuting, is for everyone to either DM chat relay in the Zoom or go to live.poshenlow.com/show and send your messages in there.
Yeah.
We don't have access to that Zoom, so we can't. And unfortunately, we do have to go on. So can everyone please mute themselves?
Yeah. Wait,
Okay.
you know what? Okay. Yeah.
It's zoom.poshenlow. Okay, it's on Vivian's screen right now.
Okay, I'm
We'll
going
give
to
you
type
guys...
it on my screen right now. Yeah, it's that. live.poshenlow.com/show.
Yes, everyone please mute yourselves and go to that link if you want to use chat. But for now, we're going to move on and go to the next question. So in the picture, each animal represents a positive integer, and different animals represent different integers. The sum of the two integers in each column is written below that column. So that's what we have here. And we want to know what the largest sum of the 4 integers in the first row. Okay, so if every animal here is going to represent a different integer, well, what I'm thinking is obviously we can't exceed the sum of every animal, which is going to be the sum of these 4 numbers, right? Because we know that, okay, so a cow plus a horse is 15, a rabbit or a bunny plus a camel is 11, some kind of big cat plus a chicken is 3, and a dog plus a turtle or tortoise is 7. So if we add these numbers up, it's the sum of every single animal. So let's add these together and see what our greatest possible sum is. Well, easiest way to do this for me is to group the 3 and a 7 to get a 10. Then put this with our 15 for a 25. Lastly, we add our 11 for a 36. Okay, so the sum of every animal together is 36. But that's not what the question's asking, is it? The question wants us to know that what's the largest possible sum of the 4 integers in the first row? Well, that's going to be these 4 animals. And the way that we can maximize that is if we give these animals the smallest possible numbers, right? Okay, so what if we do this? Let's just make a turtle 1, a chicken 2, a camel 3, a horse 4. But what do you notice? Well, if our chicken is 2, then our big cat here is going to have to be 1. And the turtle and the big cat can't both be 1. So unfortunately, we can't just do that. What I'm thinking we do next is, let's do this. Let's get rid of this 1 for our tortoise and make it 5 instead. Okay, so that means our tortoise is going to be 5, but then our dog is going to have to be 2, which won't work. All right, so just what I'm doing right now is just checking different possible values. So what if instead of making the tortoise 1, or the tortoise 5, what if I make this unerasable, what if I make this like 3? Or actually, let's make this 4. Actually, no. What value do we want to give this?
Wait, hold up, Jesse. Wait, okay, I just want to like maybe say something that might be helpful. So like maybe start with the column that adds to 3 because you actually find that like that's kind of forced. Like you can kind of force,
Oh,
at least you can force like the combination of like the two numbers, whichever order there is.
yes. Okay, yes, that's a great idea. So just what Vivian's saying is, notice that 3 has to be 1 plus 2. So let's do that. So that means either this is 2 and this is 1, or this is 1 and this is 2. But we want to maximize the number at the top. So let me make a new grid over here. It's the same thing, just written to the side so you don't have to look over an animal. So 3, 7, 11, and 15. And notice, 3 is 2 plus 1. So let's put the 2 at the top and the 1 at the bottom. Now let's go on to 7. Well, 7 can be 1 plus 6, 2 plus 5, or 3 plus 4. But notice, we already used 1 and 2, so it can't 1 plus 6 and 2 plus 5. It has to be 3 plus 4. Now we want the 4 to be on the top and the 3 to be on the bottom. Okay, now let's go on to 11, which 1 plus 10, 2 plus 9, so forth, all the way to 6 plus 5. So if we can't use 1, 2, 3, or 4, that just leaves us with the 5 and the 6 to add up to the 11, and we want the 6 on the top and the 5 on the bottom. Now it's the same thing for our last question, which is 15, and if we take away all the numbers that we've already used, that leaves us with 7 plus 8. So let's put an 8 on top, 7 on the bottom. So this means that our largest possible sum is going to be 8 plus 6 plus 2 plus 4. Now we could just like go down in the line and add them, but notice this. 8 plus 2 adds to 10, 6 plus 4 adds to 10, so 10 plus 10 is 20, which is answer choice C. See, lots of people in chat agreeing with me, so that's always a great sign. And let's check our answer. Oh, Vivian, do you have something to add?
No, I don't have anything
Okay.
to add. I just think this is a really cool problem how like everything is forced. Like the numbers were chosen very nicely.
Yeah, those were really good numbers. Like, you see, it tricked me for a little bit before Vivian pointed out splitting them into pairs. So there we go. Answer is C, 20.
Yeah, and I see a lot of people in chat were participating and putting in ideas, which is awesome too. Keep it up. Okay, so let's move on to the next problem. Wait, how many problems do we have? Okay, we have a couple more. So, okay. Ooh, we've got this one about boxes. Okay, let's see. So we have 4 of the numbers 2, 3, 4, 5, and 6. Okay, so we've got like a set of 5 numbers and we get to choose 4 of them and put them in these boxes so that the calculation is correct. Okay, and how many of the 5 numbers can be in the shaded box? Oh, so this is one of the questions like how many different possibilities are there for something? Except in this problem we'll kind of have to like count because I don't think there's any better way than just like going through them and seeing what happens. But maybe something really cool will happen. So let's see. Oh, Alex, how long does this last? This will last until 9 p.m. Eastern, 6 p.m. Pacific, so 22 more minutes approximately. Ooh, some of you remember this question. Okay. Wow. Okay, so let's see. Let's see if the last number could be 2, because like just going down the list. Let's see if the last number can be 2. If the last number is 2, then this, we need something plus something minus something else to equal 2, where all of those other somethings are distinct values in the set 3, 4, 5, and 6, because those are like the numbers left. So let's see if we can make that happen. Well, 3 plus 5 minus 6, I guess. Wait, what? Okay, anyway, so let's see. I think 3, 5, and 6 works because so you might be wondering like how I got that. Well, I just decided that I think like this number should be pretty big because we're adding two numbers and then we're subtracting another one and we're left with like a pretty small number at the end, which means the number we subtracted must be like pretty big compared to the two numbers that were added since like the sum of those two numbers is like approximately the third number. So yeah, I just chose like a big number to be here, and it works. Ooh, wow, people are saying all of them are possible. Well, let's see if we can make that happen. Let's see if that is true. So 2 gets a check mark, and I will erase this. And moving on to 3. Is it possible for 3 to be in the box? Looks like some people are saying it is possible. So let's see. If the final value is 3, then let's see. So I guess like 4, 5, and 6 would work because if like 3 plus 5 minus 6 equals 2, then increasing the 3 by 1, you get 4. So then 4 plus 5 minus 6 is like 2 plus 1, which is 3. So it looks like 3 works too. Awesome. Okay, moving on to 4. I don't quite think we can keep on adding 1 like we have been because that would kind of not work, but maybe there's another way to do it. So putting 4 here. Oh, and like I know this is kind of a stupid way, like I'm just trying things, like there's probably a smarter way to do it. Maybe we'll try something smarter like later on because like maybe I'll get tired of just bashing. But anyway, okay, so something plus something minus something equals 4. So here I think let's say we should put some like big numbers here. Like I think this should be like pretty big because like 4 is like a pretty big difference. So I think like let's try putting some like decently big numbers here. How about like 5 and 6? Wait, would that work? 11 minus 7 equals 4? No, that doesn't work because we don't have a 7. How about like 5, wait, yeah, 5 and 3 equals 8 minus 4 is 4. Oh, that doesn't work. Oh, wait, okay, Sophia, here, you see, this is where I'm looking to you guys for help. So, oh, wow, okay, people are saying 5 plus 2 minus 3. That certainly does work. So, 5 plus 2 minus 3. Yeah, because, okay, yeah, I kind of was misleading when I said big, because I guess they're not that big. But, like, 5 plus 2 is 7, minus 3 is 4. Looks pretty good. And I guess looks like 4 works. And actually, I think we can like modify this kind of to get an equation that works for 5 too, which is pretty exciting. At least I think we can. So first of all, let me put my check mark next to 4 and then okay, so here's where the magic comes. So see, I'm just going to add a 1 to the 5 and to the 4, and then we're going to get 6 plus 2 minus 3 equals 5. Boom, so it works for 5 also. And then we have one last number to check. Does it work for 6? Ooh, and wow, people are saying they have algorithms for this problem. If you would like to share your algorithm in chat, that would be amazing. Algorithms are always super cool, especially on problems where the first thing you might think of is just like trying everything or like just doing it. But okay, let's see. So can 6 be made? I have a hunch the answer is yes, just because lots of people were saying it is possible. So let's see. You know what? Maybe I'll try subtracting 2 because like why not? 2 is a small number and 6 is a pretty big number, and 2 plus 6 is like a pretty good number for the sum of two other numbers. And yeah, it looks like this works because we have 5 plus 3 minus 2 equals 6. And 8 minus 2 is 6. Yay! So I guess the answer is that they all work. And I guess like I had to just like try all of them to see, but they turn out to all work. So I guess that's a nice ending. Looks like people agree, which is great. I don't think I have the wrong answer unless I like screwed up because I'm pretty sure they all work. But okay, just to check. Yay! Awesome.
All right, awesome. Yeah, I did it basically the same way. I started based on where you did, and then I tried to modify it where possible by like either adding 1 or 2 to how many we're adding, and then subtracting 1 or 2 from how many we're subtracting. And that did work for a few of them. Sometimes I had to completely restart, but generally like adjusting one to make the next one seemed to be a pretty efficient way, I think.
Ooh, cool. Yeah.
All right, let's go on to the next question. This one looks pretty cool. I always like problems that have like shapes of cubes.
Ooh,
So
yeah.
the three pictures show a structure made from cubes as seen from the top, front, and right. What is the maximum number of cubes that could have been used to build the structure? Ooh, okay. That's pretty cool. So we're saying that like there's this structure here, let's just like call it a monument, right? We're looking at it from different angles, and these are the cubes that we see. So let's see how we could do this. So what you notice is that each of like the different angles really don't affect their other ones, right? Because say we had stairs. So if we have like 3 stairs like this. So if we look at it from the side, this is what it's going to look like. But if we look at it from the top, well, it doesn't matter how long it is. You'll just know that it's going to look like this from the top. And then from the front, it's going to look pretty similar. It's just going to look like 3 stacked up cubes. So I believe that if we take our shapes like this, when we look at it from the front, are there different dimensions? No. So
Wait,
maybe
so-
this is...
I don't know, but it might help. Like, this is just like a completely random idea, but it might help to like look at the top view map and like write in each square like the number of cubes in that column, just to like organize everything, because I'm really bad at drawing in 3D. Like, just if you need help like drawing in 3D, that's a good kind of like way to do it with cubes.
That's a really great idea. Okay, so let's do that. Let's start with our top and draw the number of cubes that we need to get the sides. So notice if we're looking at it from the top, well, it looks like it's going to be 4 wide because we have 4 here. But if we're looking at it from the front, we also have 4 wide. And we know that we only need 1 cube to be all the way on the left, and then we need it to be 3 tall in the middle and 1 tall on the back. Okay, and now if we look at it from the right, oh, do they have to be stacked all the way up? I don't think so. So that's a really good idea. So we know that we're going to have 1 in the front, 3 on the sides, in the 2 that are visible, and then 1 here, right? This is just to match with our 1, 3, 3, 1 that we see here. Because you see that if we're looking at it from the top, then, or if we're looking at it from the front rather, then only the front cubes need to be that height. So that means that this is going to be 1 tall, this will be 3 tall, and that will be 1 tall. Now let's look at it from the right. So that means that we're looking at it like from here, looking in. Well, then the front one is going to be 1. Okay, so actually the front one doesn't have to be 3 tall. It's just the tallest in this set has to be 3 tall. So, oh, that didn't work. Let's make it unerasable. There we go. So let's actually go from the side here. So the first one is going to be 1 tall. The second one is going to be 2 tall at some point. And then we're going to need 3 tall and 3 tall. So that means that this 3 right here is going to have to move farther in the back, because we're going to need a 3 to be somewhere along here and here. That's basically what the front is saying to us. So let's not place our 3s yet. But if we look from the side, well, the tallest in this row is going to be 1. The tallest in here is going to be 2. The tallest here will be 3. And then again, the tallest here will also be 3. So if we have a 1 here, I don't know, let's see, is there a way to zoom this in? Okay, let's make, oh no, that doesn't work. Okay, sorry if it's a little bit small, but I can't zoom in. But we're going to have the tallest one here be 1, and there's only 1 there, so it has to be 1 tall. The tallest one here is going to be 1, so that's also going to be 1 tall. And then the tallest in each of these middles are going to be 3. So this is just going by columns. Okay, now if we go by rows, which is if we're like looking into the right, well, we know that the tallest here is going to be 1, Well, we just said that our 1 right here is 1. So let's check that off. Let's check these off already because we did place our 1s. Then the next tallest row, well, the tallest thing here is going to be 2. And we did place a 2 already, which is awesome. But now we have to think. This one, like, let me shade it in blue for a second. This one right here, well, does this also have to be too tall? And the answer is no. Because if we're looking from the right, we're just going to see our tallest stacked, and we're not going to see the one that's like, if it's a tall one and then another tall one, well, we're not going to see that second tall one. So let's put 1 cube in here instead of 2. It's the wrong color. So that'll be 1 tall. So we checked off our height of 2 here. Now we have somewhere along here is going to be 3 tall, and we know it's not going to be our first one. So it can either be our second or our third. So let's just make it the second, and then again we can put a 1 in there. So there we go. Now all we have to deal with is this last set of 3, which means that one of these 2 here is going to be 3 tall. And this is when we go back to our front view, because we said that somewhere along here has to be 3, which means that the 3 is going to go in this spot. So that means that we have 1, 1, 1, 3. Then we're going to go top down, 1, 3, 2, 1, and lastly a 1 there. So before we check our answer or add these up, I want to check against our diagrams again to make sure it makes sense. So obviously our top diagram is right because we were just drawing on top of it. But let's look at the front. So if we're looking at the front, that means that we're looking this way. And if we just like look this way straight into it, well, that means that the tallest on this side is going to be 1. That checks out. The tallest here is going to be 3. That checks out. The tallest here will be 3. That also checks out. And lastly, our tallest one here is going to be 1. Well, that checks out too. Now let's look at it from the right, which means
hold on, Jesse. Sorry, but just to interrupt you, I think you might be solving for the minimum and not the maximum.
Oh,
okay, you have
that's
the
right.
general correct approach.
Yes.
Like, yeah, okay. Misreading is like really easy, and I've done that like, many times. So, but to find the maximum, like it's not that much different. You basically consider that like the maximum. So basically, you look at this front thing, and you find that the maximum in each of the 2 middle columns is 3. And like things can be tied for maximum. Like there can be 2 maximums, but like everything in the middle 2 columns is at most 3. And then you do the same thing for the rows by looking at this third diagram. You get this thing on the right. You basically find that the first row has everything in the first row is at most 3, everything in the second row is at most 3, and everything in the third row is at most 2. And then like you also have these little 1s here. Like you know that these 3 cells are all 1. And by the way, the numbers I'm writing in the cells are like the heights of those little towers. Like in the top view, that is. So then you just kind of like fill it in like I have done on the bottom left corner. You have those 3 1s, and then these 2, like these 2 have to be 2, or at least they're at most 2, so we can just like make them both 2. And then these other 4 in the little square, we can just make them all 3. And that is the biggest you can get. So we just have 3 plus 3 plus 3 plus 3 plus 2 plus 2 plus 1 plus 1 plus 1. And it becomes 19 if you add everything up. So yeah, this is a really cool problem. Like, yeah, it's a very, very nice logic problem. Especially because like it's 3-dimensional. You kind of have to think in 3-dimensional ways. Yeah.
Yeah, it was like a really good way to do it with writing it on. And of course, this just shows like you always want to make sure you're answering the right question, because I was just solving for the minimum, and we almost put that in as our answer, but just like Vivian said, we're actually looking for maximum. So, great catch. Thank you for that.
I mean, you probably would have noticed like when you found your answer and it was way too small, but yeah. Okay.
Yes. Okay.
Moving
so
on.
Looks like it should be 19.
Yeah. Yeah.
Yeah, just check our answer real quick. And it is 19. Awesome.
Yay. Oh, wait. Wow,
Was that our last
we're out
problem?
of questions. Wait,
Oh,
think
no.
we're out of questions. Wait, okay. In that case, I mean, we ended 5 minutes early. Not too horrible, but I guess we will have like we can have like 5 minutes of Q&A time or something, if people are up for that. Cause yeah, and by the way, like these questions are really cool. I really like them. They're pretty unique from like other math contest questions. Like the types of questions are pretty unique, and I feel like there's a large amount of logic questions, which is pretty cool. I like logic questions. Someone's asking, can we play games? So let me say, like in daily challenge classes, you'll have tons of chances to play games after class. But just for this particular live stream, maybe we'll stick to questions, like questions about like daily challenge or anything else. Yeah.
Mm-hmm. Yeah, these problems were like fun. I don't know if you guys had fun, but I did. And oh, I see people are saying it's blurry. I think that's because the tech setup to link, we're in a separate Zoom from you guys, so to link us to you guys, that computer might be having some like blur issues. But if you do want to head over to YouTube, it doesn't seem to be blurry over there.
Yeah. So okay, someone was asking about like my like labeling system. Like basically we just had the top view as like a map, and then in each square we put the number like the height of that stack. Like for example, if there was like an x here, actually no, x is like a bad number. If there was like 3 or something, then that would mean that like looking down from like an airplane, this particular stack, like that square stack is 3 high. So there's like 3 units in that stack. What grade levels are the questions? They were grade levels 5 to 6, but like Math Kangaroo is generally pretty challenging. So, and I would not be surprised if like people younger than 5th and 6th grade are also attempting this, but yeah, 5 to 6. Okay.
And I saw some people asking if this is like a live solve or like a live stream, and yes, it is. So in case you didn't notice, we have never seen the problems before, we just did. And it also is a live stream in like the literal sense, where we are live on YouTube right now, and it will be saved on there. So you guys don't need to record it, because it will be on YouTube forever after this.
Yeah. Oh, another question about the last problem we were doing. So how did I get the 19? I basically added up all the numbers that we had written down. Like for example, if our example map was like 3, 1, 2, this would be equivalent to like having 3 stacks. One of them had height 3, one of them had height 1, and one of them had height 2, and they were arranged in like a little L shape. And then to find the total number of cubes, you just add 3, 1, and 2, because those are the number of cubes in each stack. And so yeah, we just added like all the numbers and got 19. Any other questions?
Where did we find these problems? These are from Math Kangaroo. I believe it was like the exact test is 2022 grade 5 and 6 test. So that is the source of these amazing problems.
Yeah, amazing. People are asking, when does this end? This ends in approximately 3 minutes. Wow, people are asking about TED Ed. It seems like some of you have been in live classes before, because you guys know like one of the popular pastimes in certain live classes is watching TED Ed after class. Yeah.
Well,
You guys
fun.
are on live stream? Well, you technically are. Like, there's a YouTube live stream, like basically taking what's happening on this Zoom and putting it on YouTube. Technically.
Yeah, you guys aren't on it though. It's just me and Vivian.
Yeah. I'm not sure if the chat is on it or not. Yeah. Wow, okay, there's a ton of messages coming in chat. Let's see if I can even read. Oh, it looks like Lucia put like a link to like Math Kangaroo practice or something.
So let me put this on my screen for you guys.
And oh yeah, okay, I'll put this on my screen too, so that you can always see it.
Okay, lots of people are saying hi, YouTube. So in order to relay their message in case it's not showing up, anyone watching on YouTube, people do say hi.
Yeah. Ooh, people are asking when is the next session. I'm not sure when the next Math Kangaroo session is, but we usually have them like every couple of months, maybe every month or so. And
I think it might actually be every 2 weeks now.
oh, really? Wait, oh, that's awesome. Okay, so I guess there are now Math Kangaroo live streams every 2 weeks. which is really awesome. Yeah, if you like things like this. And if you're asking about like daily challenge classes in general, there's like you can sign up for daily challenge classes on the live.poshenlow.com website if you're interested in live classes, or daily.poshenlow.com if you're interested in online virtual classes. So yeah, the live classes are going to happen like extremely frequently really soon. We're going to have a bunch of new fall classes. So yeah, you can look into that.
Yes, if you like today's like structure where it's two fun people, not to call myself fun, but I like to think I am, but like two high schoolers teaching you guys some math in this exact format, then head on over to live.poshenlow.com and sign up for some of our classes.
Yeah.
And the slash show is just in case you want to look for different live solves.
Yeah. Okay, well, it's 9 p.m. Eastern and 6 p.m. Pacific, so it was awesome having this live solve with you guys. I really enjoyed the problems, and I liked seeing all of your comments in chat. You guys are certainly a bright bunch. So, yeah, have fun, and hope to see you later on maybe a live stream or maybe a live class, because I also teach live classes.
Thanks, everyone.
Thank you. Thank you. Bye. And thanks, Lucia, for like organizing this.
Thank you. Thank you, everyone, joining today's workshop. This is a great workshop. Thank you.
Thank you. Also, thanks to our moderators who have been moderating this entire time, and for all the rest of the Daily Challenge crew.
There's a lot of people working behind the scenes to make this possible.
Yep, definitely. Anyway, see you everyone. Bye. I hope you enjoyed it despite being very chaotic. Bye.
Bye, everyone. I believe that you can find some practice links and questions at this link from Lucia. Unfortunately, we don't have access to like your Zoom chat, but yeah, right on my screen right here. If you just type in this link, yeah, you might have to just type it in, yeah, and then you should be able to see it. Oh yeah, we're not leaving yet. We'll give you guys a few minutes to copy the link, ask any final questions. It probably will work without them. I don't know exactly how these links are working, but a lot of links like for websites especially, you can either have the slash or not have it. Usually it doesn't make a difference. Yes, if you are interested in seeing this session again at another time to review the questions, get some answers, have some fun, it will be available on our YouTube channel, Daily Challenge with Po-Shen Low. Yes, Professor Lowe does come to some of the live solves. Unfortunately, he couldn't come today because he's giving a tour around the country. Oh, apparently Professor Lowe is in Atlanta tonight giving a speech to some other people across the country. Which link? Yes, so this is the one for Math Kangaroo, and then this is just our link as Daily Challenge with Po-Shen Low. So there's two different links here. Maybe I'll separate them a little bit for you. Maybe that'll make it easier to see. All right. If their name is anonymous, that probably means we don't know who they are. The YouTube channel is... Let me get the exact name. It's, yeah, Daily Challenge. All right, I'll put another... This is the name of our YouTube channel. And there, if you want to see some of the other Math Kangaroo live solves, you can also watch them on our YouTube channel. Do you have to buy what? Are you talking about the Math Kangaroo? Lucia, do you know the answer to that?
Yeah, hi. Yeah, so there's some free practice online, and also the exams would be purchased, needed to be purchased. So, but there's still some free examples online. And also Math Kangaroo has some group and private lessons, so they will share all the past tests with the students. Hope this help to answer your question. Yeah.
Awesome, thank you. All right, I see, I can't tell the exact number. It looks like we do still have a bunch of people in the Zoom. Do we have any remaining questions? Well, we did do some of the questions from the test. We didn't do all of them. Yeah, it would be strange if someone joined now.
Jessie? Yeah. Jessie?
Mm-hmm.
Jessie, could you help to share this link?
Oh, yes, I will put that link on my screen. Okay. Here are the links for, these are the, oh, I'm Jesse. I'm one of the TAs of Daily Challenge. And these are links that you can use to access the Math Kangaroo stuff.
Yeah. So the top link for the ongoing classes, that's for the Math Kangaroo ongoing classes, the top link. The second link, that's for practice materials. So you all can free to check. We have some classes ongoing now. Once you join as a student, you will get the free test for all the parts.
All right, awesome. So thank you everyone who's still here. I believe we're gonna close the Zooms down now and the stream's gonna end. But thanks everyone for coming, and we hope to see you at another live solve. Thank you, Lucia. Oh, I think that means it. Did it close? All right, looks like it's ended. So thank you everyone who might still be there. Thank you, Lucia.
Thank
Bye.
you. Bye. Have a good weekend.
You too.